Hello guys, so I'm back. So for today we're going to deal with factoring quadratic trinomials. So that is in the form of x squared plus bx plus c. Okay, so we have here some steps to follow when factoring quadratic trinomials. So number one, okay, so we list all pairs of integers whose product is c. So again, list all pairs of integers whose product is c. Okay, so this is your c. Okay, then step number 2. Okay, so let's choose a pair. So from the many pairs we choose one, and then let's call it m and n. Okay, whose sum is b. So that is m plus n that is equals to b. So this is the b part. Okay, and then for third part or third step, so you just follow the factorization formula for this. So that would be x squared plus bx plus c. That would be simply equal to x plus m quantity x plus n. Okay, so again for number 4, so some notes. So if there are no such integers m and n, okay, such that m plus n is equals to b, so the trinomial cannot be factored, and it is called a prime trinomial. Okay, so no integer m and n, okay, such that m plus n is equals to b, so therefore this is called a prime trinomial. Okay, so let's have some examples. Okay, so example number 1. Okay, so I have here let's factor out x squared. Okay, so x squared plus 10x plus 16. Okay, so just follow these steps. Okay, so first step, list all pairs of integers whose product is c. So your c here is, okay, so for step number 1, your c is 16. So what are the pairs of integers? That's a product of 16, so that would be, okay, so let's okay, I'll make here a table. So factors of 16, okay, so that would be 1 and 16. You have 2 and 8. Then you also have 4 and 4. Okay, so these are the list of pairs whose product is c or 16. Okay, so step number 2, choose a pair m and n. So I will choose from here, so whose sum is b. Okay, so let's get the sum. Okay, change the color. So 1 plus 16, that would be 17. 2 plus 8, that would be 10. 9 plus 4, that would be 13. Okay, so afterwards, let's take a look. What is the pair of integers that gives us the sum of b, and that is 10? So as you can see, this pair gives us sum of 10. Okay, so therefore we proceed with number 3. So we use the factorization for x squared plus bx plus c, and that would be So this will be equal to, okay, x plus, okay, so we use 2 here, and then x plus 8. Okay, so this would be your final answer. Okay, so another example. So example number 2. Have here x squared minus 9x plus 18. Okay, so first, okay, I'll look for the list of all pairs of integers whose product is C. Again, that would be factors of 18. So factors of 18 are, okay, so we have here, you can use negative. Okay, so as long as the factor is, or as long as C is equals to positive 18. So let's have negative 1, negative 18. Okay, then we have negative 2, negative 9. We also have negative 3 and negative 6. Okay, so and then we get the sum. Okay, get the sum. So negative 1 minus 18, or negative 1 plus negative 18, this would be negative 19. Negative 2 plus negative 9, that would be negative 11. Negative 3 plus negative 6, that gives us negative 9. Okay, then looking at the pairs, so choose this one, the negative 3 and negative 6, because it gives us a sum of negative 9, which is letter B. Okay, so therefore our answer would be factor of this is equals to x minus 3, then x minus 6. So this will be now your final answer. Okay, so how about you try this one? Try this. Okay, so you need to factor this completely. So for letter A, we have x squared plus 12x plus 27. Then for letter B, we have x squared minus 13x plus 36. Okay, so how about this? How about let's try to answer this question. Okay, so find all integers. Find all integers k. Call that k, for which x squared plus kx plus 32 can be factored. Oops. Okay, so again, we need to find all integers k. So for which x squared plus kx plus 32 can be factored. So here we're going to have to approach k. So we know that we can have a positive value of k and as well as the negative value of k. So let's solve first for the positive value. So for k greater than 0, okay, so again I'm going to list all the integers or pairs of integers that can be a factor of 32. So factors of 32, okay, factors of 32 are definitely 1 and 32. We have 2 and 16, and then we have 4 and 8. Okay, so get the sum. So the sum here, okay, I have here 33, I have here 18, I have here 12. Okay, so well, as you all know, sum is equivalent to b, okay, or in this case equivalent to k. So that's what we're looking for. Okay, so but taking the negative of the value of b, so we have here for k less than 0. Okay, so we need to find the factors. So factors of 32. Okay, so we have here negative 1, negative 32, negative 2, negative 16, and then we have negative 4 and negative 8. Okay, then we get the sum. Okay, So sum, change my color. Okay, so sum is equal to negative 33, negative 18, and negative 12. So again, sum is equivalent to B, in which in this case equivalent to C. Therefore, okay, the list or of all integers k, so for which x squared plus kx plus 32 can be factored, so so that will be k is equals to, again, take the positive and then the negative, so plus minus 33, you have here plus minus 18, and then plus minus 12. So here are the values of k for which this expression can be factored. Okay, so how about try this? Okay, so try this. Okay, so find all integers k. Find all integers k for which x squared plus kx plus 48 can be factored. So good luck. Okay, how about this next example? So let us factor x squared plus 3x plus 3. Okay, so again we must just follow the steps. So if we're looking for factors of 3, okay, so factors of 3, so that would be 1, 3, or negative 1, negative 3. Then we get the sum. So sum is equivalent to 4. This would be negative 4. As you can see, when we take the sum of the pairs of integers, it is factor of 3. So we don't have a value of 3. Okay, we have here 4 and negative 4. So therefore, we can consider this expression A. So this is what we call the prime trinomial. So again, we define prime as the factor or a certain expression or a number wherein the factor is 1 and itself. So therefore, this cannot be factored. So the factor of x squared plus 3x plus 3 is 1 and itself. So, okay. So how about you try this? Then explain. Okay, then explain why we can't factor this one. So factor x squared plus 4x plus 5 if possible. So if not possible, explain why. Okay, so that's it for factoring quadratic trinomials.